Hello guys, welcome back to another coding video. Today we're going to be doing our part 2 of our NumPy module tutorial. If you have not watched the part 1, please do so. I will put one of those little buttons up on screen for you to click. It'll be great if you could go and watch. Again, please subscribe down below if you find this helpful. If you didn't, well, it's okay. You don't need to subscribe. But anyway, let's get straight into this video. Today, we're going to start off with NumPy copy and view functions, right? Now, there's a difference between copy and view. The difference is very small, but there's still a difference. The copy, right? When you copy an array, then you have a basic, double of the array. It's between the original and then the new duplicate array, but view is just a view output of the original array, right? The copy will, if you copy a array and change the copy, it will not affect the original data, and any changes to the original data will not affect the copy. However, with view, if you change data while in view, it will change both. It will change the original array also. So really quickly, I will show you how to do a copy function. So we will create an array called ARR. And then this is, again, if you have not watched my first video, please do so. It'll help a lot with understanding what I'm doing here. So right now, I'm creating a NumPy array. And then we're going to have a variable called copied. And then we're going to do ar.copy. This is the function to copy an array in NumPy. So now we have two arrays, right? The ARR array, which is the original, and then copy, which is, of course, the duplicate. So then we can change ARR, okay? If we change ARR, copy will not change. Actually, I should name this copy. There you go. So if we do ARR0 maybe equals a number such as 53, right? And then if we print ARR, and then if we print copy, we can see that ARR has been changed, as index 0 is 53, as you can see here. But copy has not been changed, and copy is still the original array. This is because, again, when modifying an array, the copy will not be changed. This is the same if we change copy 0 into 53. Then the original will stay the same, but the copy will change. That's very simple. Now let's move on to view. So when you change something in view mode, it will affect both arrays. So we're going to change that into view. Okay, and then now if we change array 0, then copy will also become 53 as index 0. As you can see here, 53. If we change copy index 0 to 53, it will be the same thing. Why? This is because in a view function, right, both arrays will be changed if you try to change one array. So that would be array, view, and copy mode. But now we can check if the array owns its own data. So as an example here, we have another array. Then we're going to have variables x equals array.copy. So imagine, okay, just pretend that you don't know if x, like, you don't know if x is view or copy, and you don't know if y is view or copy. Then what you can do is that you can do the .base function. So what you do, right, is print x.base. That just basically tells the code to to output who owns the array. If we run this, you can find that, first of all, the copy is owned by no one because it's just a copy of the actual array. No one actually claims it. While view, it is the original array itself, so it prints out 1, 2, 3, 4, 5, 6, 7 because that is the actual array. So this is the copy versus view difference and how to check if a array is a copy or a view. So moving right on, there's something called NumPy array shape. The shape of an array is the number of elements in each dimension. Again, if you did not watch my last video, I'm not going to exactly explain that dimensions here because it'll take too long. But again, please go watch my other video if you want to learn about dimensions. NumPy arrays have an attribute called shape, right? That returns a tuple. That tells the user the number of elements per dimension as parameterized. So we're going to use this same example. However, we're going to create a 2D array. So let's really quickly create a 2D array. There we go. So we now have a 2D array. Okay. And then if we print array.shape, it will print 2, right? And then a comma. And there is a comma here. Usually, this last value will print how much elements are in a dimension. However, because we have different elements, a different number of elements per dimension, we can't do that. If I change this also to 5 elements per dimension, so that it prints 5, because there's 5 items per dimension in this whole array. The first value is just how many dimensions there are. This is a 2D array. Again, we can use other functions such as ndim equals 5. We print that. It'll print this very large thing because we have changed the dimension, right? So that the arrays will first of all be encased with more brackets, and NumPy will read those brackets each as a specific array with their specific items. So there is also something in NumPy called array reshaping. Reshaping basically means changing the shape of an array, so changing the dimensions and what are in those dimensions. So we can add or remove dimensions and change the number of elements per dimension. So that is pretty simple. So let's say we have a one-dimensional array. So here we have a one-dimensional array. And now let's have a new variable called modified array equals ar.reshape. So that's a command. And there's 2 variables here. So okay, the first parameter, right? It will declare arrays, the number of arrays, and the second will declare how much elements are there per array. So if we do, for example, actually no, we should start off with something easier. So let's do 3, 3. Print that. Oh no, we should print that. Print mods array. Oops. Mod. So there you go. We print that. We get, first of all, a 3-dimensional array, 1, 2, 3, 4, 5, 6, 7, 8, 9, that are split up into 3 items per array. Now, you may ask, why didn't I do 4, 3? Well, that's because if you try 4, 3, there is an error because you can't split an array with 9 items into 4 arrays with the same amount of items. You can only do 3. However, if we added a few more values, make it 12 items, then we can do for 3, as you can see here. So basically, this times this number will have to equal the amount of items in the array for this to be able to work. So that is pretty convenient. And then if we want to change this into a 3D array, we just add more parameters, right? So the first parameter is the topmost level of array, then the next level, and then finally how much items are in the array, right? So as you can see here, there are 2 arrays containing inside 3 more arrays, with each of those arrays containing 2 items. Again, if we multiply these together, 2 times 3 times 2, we get 12, because that's how it fits. If we were to do 9, right, we can do 9 is not a very good number, so let's try 8 actually. If we do 8, we could do 2, 2, 2. I'll be correct, because 2 times 2 times 2 equals 8. So this means there's 2 large arrays with 2 arrays inside of one of those, and 2 items per array. It's a bit confusing. You may want to Google this, array dimensions, just to clear everything up. Actually, no, this sort of like array reshaping kind of can be used actually in like a lot of places. So for example, if you wanted to split an array of numbers into smaller parts, to just like a tree diagram, to be able to calculate each one, that'll be extremely easy to do. So let's quickly get rid of that. Right. Next, we will learn about joining arrays. Right. So joining arrays, we can have array 1 and we have array 2, right? And then we just really quickly create 2 basic one-dimensional arrays, as you can see here. And then once that is done, we can join them, which basically means concatenating them. However, if you just try doing, normal Python, so let's say in normal Python, you can concatenate strings by just doing addition sign, but you will get an error. Why? It's because this is NumPy arrays, and you can do that. See, if we run this, we can get. Oh, we don't get an error. Let's see here. Let's print full array. Not sure what's happening. Let's real quickly get rid of that. Let's see. Okay, yeah, no, it just adds them together. Parallel. Yeah. So if you do addition, it will just add each index together with the other corresponding index of the other array. So to actually concatenate them, you have to do the NumPy.concatenate format. Concatenate, there we go. I do not know how to spell that. That's why I need to rely on autofill. There we go, should be good. Oh, what is this? Scalar. Oh, okay, nope. Sorry. I have to add an extra pair. There we go. As you can see, 1, 2, 3, 4, 5 has been concatenated into one full array. Right. And then you can also join 2D arrays by doing something called axis. And axis will basically allow you to choose where you want to join those arrays. Let's say we have 1, 2, and then 3, 4, and then let's have just another pair. 3, 4, 5, 6, 7, 8. Perfect. And so now we have the 2D arrays, right? Next, what we're going to do is that we're going to add another function outside of the tuple brackets. Axis equals 1. if we run that, we can join everything together. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say if we do axis equals 2, then what will happen is that axis 2 is out of bounds because we can't actually put a split axis of 2. However, we can put a split axis of 0. As you can see, and basically what this will do is that this tells the code where to cut the code, right? So as you can see, axis 0 is different from axis 1. And that is because axis 1 is horizontally, as you can see, while axis 0, right, is vertically. So that's pretty simple. You can also, right, use a NumPy, something called a helper column, so you don't need to mess around with axes anymore, right? You can use something called hstack and vstack. Hstack will join it along horizontally, so this is basically the same as axis. It's the same as, I believe, axis 1. Not very sure. I think it's axis 1. Yeah, it is the same as axis 1, right? And then there's vstack, which is the same as axis 0. You can see hstack, vstack. So no more messing around with axes if you have hstack and vstack down. So there is one last function here, and that's called dstack. Dstack will stack it along by height. So 1, 2, 5, 6, right? And then you'll split right here, and then 3, 7, 4, 8, 4, 8. So dstack will split it by height, which is the same as depth. So dstack means depth stack. So this will conclude today's NumPy tutorial. I hope you guys learned something. If you did, please leave a comment down below. We actually didn't finish NumPy. I still have a lot more to go through, so we might do a part 3 maybe. Yeah, we might do we will do a part 3 because it's just better. But I do want to do something real quick. If you guys know about the website called LeetCode, it's a website which will allow you to basically practice coding questions from companies around the world. I wanted just to do a few problems on LeetCode because I thought, why not, teach some more stuff. So this is not about NumPy, but it's still fun to do, as this is a coding channel. So the question here, right, is that given a binary array, find the maximum number of consecutive ones in this array. So the input is 1, 1, 0, 1, 1, 1, and the output would be 3 because at the end there's 1, 1, 1, and that is the longest string of consecutive ones. So the algorithm here is basically to scan the array and have two variables, a output variable and a temporary variable. The temporary variable will calculate the amount of, I say, streaks or like streak ones, so like the amount of consecutive ones, and that will compare it to the maximum number of ones, and if it's larger, then it will replace maximum with temp. I will show you as soon as we write this code. So for the function find max ones, and the variable will just be array. Right, let's do the temporary variable, let's do 0. Let's do max, which means like the maximum like streak of ones or consecutive ones. And then we scan the list, so for I in array, right? So this is basically just telling the code, if you read 1, right, then temp, you add 1 to temp. That's pretty simple because you're adding one to the consecutive one counter basically. And then you ask, right, because you have a temp now, you need to put the temp into the max variable. So you do max equals, and then the Python function max, which you'll find the maximum between two variables. And right now, of course, the maximum is temp because the maximum okay, now I shouldn't name this as something else. So yeah, I'll just name this the output as out. So right now the output variable is 0, while the temporary variable is already 1. So output will become 1. That's useful as we keep stacking along the streaks. Then we have an else statement, and temp equals 0. That is just to cut the streak. So for example, right, in a game, you are having a kill streak. Your kill streak adds every time you kill someone new, right? However, if you die to someone, then your kill streak resets. Here, the ones are like your kill streaks, and your kill streak will add in this line. And then as soon as you die, which is right here, your kill streak will become 0 again. Then we just need to return maximum, which in my case I'm doing return. This is quite similar to do in Java. The variables are the same. You can just again for loop through the array, do some if statements, and then max. Find online. Just Google find maximum number documentation function Java or something like that. So if we run this, right, let's get some driver code going. Okay, so let's see, find max 1, and let's do the array 1, 1, 1, 0, 0, 1. Oops, okay, yeah, there we go. Okay, I have to put that, sorry. There we go, 3. Why? Because the longest string of consecutive ones is 3, right? 1, 2, 3. There is a 1 here, however, this one is not the longest streak. If we add some more ones to the end, we can find that it now says 6 because the length of this, right, that's 6. So that concludes this, like a short problem solve. So I hope you guys enjoyed today's video. If you did, please leave a like down below, subscribe, comment what you want to see next. Yeah, have a good day.